All right, here we go. We are on the 11.2 intervention. Remember, you only watch these after you have done the problems. Really don't use this as a learning opportunity. Go back and review some of the past tests or review your notes. Those are the learning opportunities. This you're going to do after you've done the problems. Now, there are two sets of problems, so you can certainly do the top problem. Try it. If you got it right, great. Fast forward to the end, check the answer on the bottom. If you didn't get it right, review it again and then rework the bottom and then go to the end and check. So we're doing what are called direct variation problems here. This is direct variation and what we call a constant of variation. And the concept of a constant is a value that doesn't change. That's what constants are in mathematics. Constants are values that don't change. So what they're telling us here is, in this case, we can predict what any given weight will do in terms of stretching the spring, how long any weight will stretch the spring because there's a constant value. The formula for finding the constant of variation, anytime you want to find the constant of variation, that is equal to the dependent value which we know is the effect, it's what happens, divided by the independent value. Or what we call the cause. So one of the first things we have to do is identify the independent and the dependent. In this case, the amount of weight we put on is independent. We control that. I decide how much weight I'm going to put on the spring. How far it stretches, that is dependent. That depends on how much weight I decided to hang on the spring. So in each of these, when we want to find that constant of variation, constant of variation, we are going to divide, we're going to take a pair, here's a pair, and we're going to divide the dependent by the independent. And 5 divided by 2 is 2.5. I'm going to show it a slightly different way. Actually, 5 divided by 2, that's a simplified fraction. I'm going to leave it that way. Let me show you the next pair. 10 divided by 4. Well, 10 divided by 4 simplifies to 5 divided by 2, which we just said was 2.5. Let's do one more. Let's go all the way out to the end of our table. 25 divided by 10 is 2.5. It also, by the way, simplifies to 5 over 2. 25 is 5 times 5. 10 is 5 times 2. So our constant of variation is 5 over 2. The second part says write an equation that you could find the distance the spring stretches. We're going to call that D. We're going to say D is equal to distance spring stretches when a given weight is applied. When we put on a given weight, and I'm going to call that given weight value W. That's the weight. And my equation is as follows. If I take my constant of variation and I multiply it by the weight, I will get the distance the spring stretches. If I take 2.5 and I multiply it by 8, right here I get 20. 2.5 times 6, I get 15. I can know that formula is true. Let's just do a couple of those that I just mentioned. 2.5 times 8 gives me 20. I know from the table that that's one of those that works. A second one, 2.5 times 6 gives me 15. And just in case you're one of those people that needs to be shown that, you need the proof of it, I'll show you some proof. 2.5 times 6, there's my 15. 2.5 times 8, there's my 20. So that's constant of variation. Go ahead and pause the video now. Check your work on the second problem. If you got it right, great. Fast forward to the end, see how you did. If you didn't get it right, pause the video for a little bit longer and rework the problem so you know what you're doing. All right, let's check our work on the second one. You can see I've already written down a lot of my my definitions and whatnot. Again, constant of variation, dependent divided by independent, effect divided by cause. So we identify those. We're dealing with another spring problem. The amount of weight we put on, we control that. That's the independent. The distance that spring is going to stretch, that's the dependent. So in this case, let's just go through and look at a couple of these. 7/2, that's our constant of variation. Let me grab my calculator out and I'll stick it right there, I guess, temporarily. There's not a lot of room here. 7 divided by 2 gives me 3.5. Let's see if that's true for another one. And if we did it right, it should be true for all of them. 28 divided by 8. 28 divided by 8, 3.5. By the way, 28 divided by 4 is 7. 8 divided by 4 is 2. We can see that we have that same fraction. All these will simplify to the same fraction. Let's shove our calculator out of the way here and just do one more freehand. 35/10. It's always nice dividing by 10 because it just moves a decimal one place. Again, 3.5, and again, 7/2. So when I get down to my formula is going to be my constant of variation times the weight equals the distance. And I can check that, if I bring my calculator back for a minute, I can check that by taking 3.5 times 6. I'm doing this one now. 3.5 times 6. 3.5 times 6 equals, there's the 21 it was supposed to equal. And let's do one more. Let's do this one right here. 3.5 times 4, will that be 14? 3.5 times 4 equals, and there's my 14. All right, so that is your work on 11-2. Remember, be sure you understand this well before you come take the intervention test. If you need some additional review, go back and look at the week 13, week 12, and week 11 tests. All of those had concept 11-2 on them. Additional questions, as always, be sure you bring them to me.